students, welcome to this lecture one polynomials. So in today's lecture, we'll discuss exercise 2.1 one polynomials. Okay. So first we recall when studying polynomials, you often hear the terms zeros, okay, and roots and factors and x-intercept. So x is equal to a is said to be zeros of a polynomial p of x if p of a is equal to 0. Okay, and x minus a, this is called a factor of a polynomial p of x when p of a is equal to 0. Okay, so if x minus a is a factor of a polynomial p of x, then p of a should be 0. And x-intercepts, that is the coordinates at x-axis. Okay, so the coordinate of x-axis look like a comma 0. So a comma 0. So where the x-intercepts is basically x equal to a. Okay, so the x-intercept of these coordinates is a. So we know already about these terms. Okay, so when we study polynomials, that case we often hear these terms. Okay, so you must be kept on your mind about these terms. And we here discuss fundamental connections for polynomials functions p of x and a real number a. Okay, so if we have a polynomial p of x and real number a, okay, then these following statements are equivalent. Okay, so these following statements are basically equivalent to each other. So in first statement, we have a is a root or solution of the equation p of x is equal to 0. Okay, so if we solve p of x is equal to 0, then we will get x is equal to a. Okay, then a is said to be a root or solution of the equation p of x is equal to 0. And if a is a 0 of the function p of x, that means a is said to be 0 of the function p of x when p of a is equal to 0. Okay, that means when we replace the value of x with a in polynomial p of x, then if we get p of x is equal to a is equal to 0, then a is called 0 of this polynomial p of x. Okay, and a comma 0, this is an x-intercept of the graph y equal to p of x. Okay, and here the x coordinate is a, and a is basically 0 of this quadratic polynomial p of x. So 0 of this polynomial p of x. Okay, and x minus a, this is called a factor of the polynomial p of x. Okay, when x minus a is a factor of p of x, then p of a should be 0. Okay, so these four statements are basically equivalent to each other. Okay, so you can prove it. If a is a root or the solution of the equation p of x is equal to 0, then it implies a is a 0 of the function p of x. Okay, so these two statements are true. And you can also show if a is a 0 of function f of p of x, then a comma 0 is an x-intercept of the graph y equal to p of x. So this two statement is also equivalent statement. Okay, and if a comma 0 is an x-intercept of the graph y equal to p of x, that means y equal to p of x cuts the x-axis at a comma 0 point. Okay, and here the x coordinate is a. So this and this a is a 0 of p of x are equivalent statement. Okay, and if a comma 0 is an x-intercept of the graph y equal to p of x, then you can say x minus a is also a linear factor of p of x. So these two statements are also equivalent to each other. Okay, so this is how you can show all these statements are actually actually connected to each other. Okay, that is, the following these four statements are equivalent to each other. Okay, so now come to exercise 2.1. So here in this exercise, here we have given y equal to p of x, graphs of y equal to p of x. Okay, for some polynomial p of x, and we need to find the number of zeros of p of x in each case. Okay, so for finding zeros of the polynomial p of x, we need to draw first the graph of the function of y equal to p of x. Okay, and we know if y equal to p of x cuts the x-axis, then we'll get zeros. Okay, otherwise we'll not get any zeros. Okay, so if the graph of y equal to p of x cuts at some point at x-axis, then the x coordinates of those points where the graph cuts the x-axis are called zeros of the polynomial p of x. Okay, so basically for this exercise we need to check whether where the graph of this function y equal to p of x, that is graph of this polynomial, cuts the x-axis or touches the x-axis. Okay, so let's see the figure. So in figure 1, here we have given this graph. Okay, so this is actually our y equal to p of x, the graph of y equal to p of x. Okay, and here you can see the graph of y equal to p of x does not cut at x-axis. Okay, so here basically this graph does not cut at x-axis. So for this graph, the number of zeros of the polynomial p of x basically 0. Okay, there are no zeros of this polynomial p of x. So number of zeros for this graph is 0. And if we see figure number 2, so here you can see the graph of y equal to p of x cuts the x-axis at some point here. Okay, I'm naming this point A. So here the graph cuts the x-axis at exactly one point. Okay, so here the number of zeros, basically the zeros of this coordinate equation, basically the x coordinates of a point. Okay, so therefore for the graph y equal to p of x, the number of zeros of p of x is 1. Okay, so number of zeros for this of polynomial p of x is 1. Now let us see figure number 3. So here in this figure you can see the graph y equal to p of x cuts the x-axis at this point, and this point. Okay, so at 3 points the graph of y equal to p of x cuts the x-axis. Okay, so here we can naming this point A, this is B point, and this is C point. So here the zeros of this polynomial p of x are basically the x coordinates of the point A, B, and C. Okay, so the number of zeros of p of x is 3. So for this graph, the number of zeros is 3. Okay, and now if we see the graph figure number 4, so here the graph of y is equal to p of x. It cuts the x-axis at 2 points. Okay, this point and this point. So naming A, this is B. So here the zeros of this polynomial p of x are the x coordinates of A and B. Okay, so here the graph cuts the x-axis at 2 points. So the total number of zeros of p of x is 2. Okay, so for this graph the number of zeros is 2. For this graph number is 3. Number of zeros is 3. Okay, And now if you see figure number 5, so here you can observe that the graph y equal to p of x cuts the x-axis at this point, at this point, at this point, this point, and this point. Okay, so at 4 points the graph cuts the x-axis. Okay, so here this is a, this is b, this is c, and this is d. So here the zeros of the polynomial p of x are basically the x coordinates of a, b, and a, b, c, and d points. Okay, so here at 4 points the graph cuts the x-axis. So the total number of zeros for the polynomial p of x is 4. Okay, so number of zeros is 4. And now if you see this graph, figure number 6, so here you can observe that the graph y equal to p of x, y equal to p of x does cuts at 1 point and touches at 2 point. Okay, touches at 2 point. So here at 1 point the graph cuts the x-axis, and at 2 point the graph touches the x-axis. Okay, so here at total 3 points the graph cuts and touches the x-axis. Okay, so if we naming this point a, this is b, and this is c, then the zeros of the polynomial p of x are basically the x coordinates of the point a, b, and c. Okay, so here you see here at 1 point the graph cuts, and at 2 points the graph touches. Okay, so the total number of zeros of p of x is basically 3. Okay, so for this graph the number of zeros is 3. Now let us solve exercise from 2.2. Okay, so here in first question number first, here we have to find the zeros of the polynomial of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Okay, so we have given this first quadratic polynomial x squared minus 2x minus 8. Okay, so let us see first the zeros of this quadratic polynomial, and we will verify the relationship between the zeros and the coefficients. Okay, so let us see question number 1. So here we have given this quadratic polynomial x squared minus 2x minus 8. Okay, so we can here factorize this quadratic polynomial by using splitting the middle term. So here middle term is minus 2x. So minus 2x can be split as minus 4x minus 2x. Okay, so if we splitting the middle term minus 2x as minus 4x minus 2x, then the quadratic polynomial x squared minus 2x minus 8 can be written as x minus 4 times x plus 2. Okay, so here we can split minus 2x as minus 4x plus 2x. Okay, so then we can write this is equal to x minus 4 times x plus 2. Okay, and the value of x squared minus 2x minus 8 is 0 when x minus 4 is equal to 0 or x plus 2 is equal to 0. That is when x is equal to 4 or x is equal to minus 2. Okay, so therefore the zeros of x squared minus 2x minus 8 are 4 and minus 2. So the zeros of x squared minus 2x minus 8 are 4 and minus 2. Now we have to verify the relationship between zeros of this quadratic polynomial and coefficients of its. Okay, so we know sum of its zeros is equal to minus of coefficient of x divided by coefficient of x squared. Okay, and we also know the product alpha times beta, this is equal to constant term divided by coefficient of x squared. Okay, so here we have to verify that. So here the sum of zeros, that is equal to 4 minus 2, since 4 and minus 2 are the zeros of this given quadratic polynomial. Okay, so sum of its zeros, this is equal to 4 minus 2 and this is equal to 2, and this can be written as minus of minus 2 upon 1. Okay, and this is equal to minus of coefficient of x divided by coefficient of x square, and product of its zeros, that is equal to 4 times minus 2. Okay, and this is equal to minus 8, and you can write minus 8 as minus 8 upon 1. Okay, and this is equal to constant term divided by coefficient of x square. Okay, so this is equal to constant term by coefficient of x square. So here verified the sum of its zeros is equal to minus coefficient of x divided by coefficient of x square, and product of its zeros is equal to constant term divided by coefficient of x square. Okay, so now for question number 2, here we have given this quadratic polynomial 4s squared minus 4s plus 1. Okay, so first we have to find the zeros of this quadratic polynomial. Okay, and then we have to verify the relationship between the zeros. Okay, so here we can write this quadratic polynomial as 2s minus 1 whole square. Basically, this quadratic polynomial in the form a square minus 2ab plus b square. Okay, and we know this is equal to a minus b whole square. Okay, so 4s square minus 4s plus 1, this is equal to 2s minus 1 whole square. Okay, and the value of 4s square minus 4s plus 1 is 0 when 2s minus 1 is equal to 0, that is s is equal to 1 by 2. Okay, so the zeros of 4s square minus 4s plus 1 are 1 by 2 and 1 by 2. Okay, so sum of zeros, this is basically equal to 1 by 2 plus 1 by 2, and this is equal to 1, and you can write this is equal to minus 4 upon 4, and this is basically equal to here the coefficient minus of coefficient of s divided by coefficient of s square. Okay, so here the verified sum of zeros is equal to minus coefficient of s divided by coefficient of s square. Okay, and if we take product of its zeros, that is 1 by 2 times 1 by 2, that is equal to 1 by 4. Okay, and if we see the constant term for this quadratic polynomial, that is 1, and the coefficient of s square, that is 4. Okay, so the product of its zeros, that is equal to 1 by 4, and this is equal to constant term divided by coefficient of s square. Okay, so verified. So now for question number 3, so here we have this quadratic polynomial 6x squared minus 3 minus 7x. Okay, so let us see first what are the zeros of this quadratic polynomial, and then we will verify the relationship between the zeros and the coefficients. Okay, so we have given this quadratic polynomial 6x squared minus 3 minus 7x. Okay, so you can rearrange this quadratic polynomial as 6x squared minus 7x minus 3. Okay, and if we now use splitting the middle terms, okay, then you will get this is equal to 3x plus 1 times 2x minus 3. Okay, and the value of 6x squared minus 3 minus 7x is 0 when 3x plus 1, this is equal to 0, or 2x minus 3, this is equal to 0. Okay, that is x is equal to 1 minus 1 by 3 and or 1 x equal to 3 by 2. Okay, so the zeros of this quadratic polynomial are minus 1 by 3 and 3 by 2. Okay, so sum of zeros, this is equal to minus 1 by 3 plus 3 by 2, that is equal to 7 by 6. Okay, and this is equal to minus of minus 7 by 6, and here the coefficient of x is minus 7 and the coefficient of x square is 6. Okay, so this is equal to sum of its zeros equal to minus of coefficient of x divided by coefficient of x square. Okay, And now product of its zeros, this is equal to minus 1 by 3 times 3 by 2. Okay, and this is equal to minus 1 by 2. And you can write this is equal to minus 3 by 6. Okay, and here for this quadratic polynomial, the constant term is minus 3 and the coefficient of x square is 6. Okay, so here minus 3 upon 6, that can be written as constant term divided by coefficient of x square. Okay, so now verified this also. Okay, now we'll see. So now for fourth number quadratic polynomial. So in fourth number quadratic polynomial, we have 4 square plus 8u. Okay, so let us see how we'll find the zeros of this quadratic polynomial first. Okay, so in fourth one, we have given this quadratic polynomial 4u square plus 8u. Okay, and now if we rearrange this, then you can write this is equal to 4 square plus 8u plus 0. Okay, and now if we common out u, 4u, then you will get this is equal to 4u times u plus 2. Okay, and the value of 4 square u square plus 8u is 0 when 4u is equal to 0 what u plus 2 is equal to 0. That is when u is equal to 0 or u is equal to minus 2. Okay, so therefore the zeros of 4u square plus 8u are 0 and minus 2. Okay, so now sum of its zeros, that is equal to 0 plus minus 2, and this is equal to minus 2. And you can write this is equal to minus 8 upon 4. And here the coefficient of u is 8 and the coefficient of u square, this is equal to 4. Okay, so here this number minus 8 upon 4 is equal to basically minus coefficient of x u divided by coefficient of u square. Okay, and now product of its zeros, this is equal to 0 times minus 2. Okay, and this can be written as 0 and 0, this is equal to 0 upon 4. Okay, so 0 upon 4, here the constant term is 0 for this quadratic polynomial and the coefficient of u square is 4. Okay, so 0 upon 4, this is basically equal to constant term divided by coefficient of u square. Okay, now let us see fifth number quadratic polynomial. So here we have given t square minus 15. Okay, so here I will do this exercise, then I will give you sixth number as your homework problem. Okay, so sixth number your homework problem, and here I will do fifth number. So now in fifth number we have t square minus 15. Okay, so we can write this is equal to t square minus 0 times t minus 15, and we can factorize this is equal to t minus root over 15 times t plus root over 15. Okay, and the value of t square minus 15 is 0 when t minus root 15, this is equal to 0, or t plus root 15 is equal to 0. Okay, and that is when t is equal to square root of 15 or t is equal to minus square root of 15. Okay, so therefore the zeros of t square minus 15 are root over 15 and minus root over 15. Okay, so the zeros are plus root over 15 and minus root over 15. And now sum of its zeros, that is minus root square root of 5 minus square root of minus 5, this is equal to 0. Okay, and you can write this is equal to 0 upon 1, and this is basically equal to coefficient of t divided by coefficient of minus of coefficient of t divided by coefficient of t square. Okay, so verified. So now product of its 0, that is root 5 into root minus of root 5. Okay, and this is equal to minus of 5, and you can write this is equal to, and you can write, sorry, root 15. This is root 15 also. Okay, so this is equal to minus 15, and this can be written as minus 15 by 1, and here the constant term is minus 15 and the coefficient of t square is 1. So this is equal to constant term divided by coefficient of t square. Okay, so verified. So now let us move to exercise 2. So in exercise 2, here we have to find a quadratic polynomial each with the given numbers as sum and product of its zeros respectively 1/4 and -1. Okay, so this is sum of its 0 and this is product of its 0, and this is sum of its 0 and this is product of its 0. Okay, and this is sum of its 0 and this is product of its 0. Okay, so let us see how to solve. So here we have given this sum of its 0, that is 1/4, and sum of product of its zeros -1. So here we let first polynomial be ax square plus bx plus c, and its zeros be alpha and beta. So sum of its zeros, that is alpha plus beta, this is equal to 1/4 and this is equal to minus b upon a. Okay, and product of its zeros, that is alpha times beta, this is equal to -1, and you can write this is equal to minus b minus 4 upon 4. Okay, and this is equal to c upon a. So now if a is equal to 4, then b is equal to -1. Okay, and c is equal to -4. So therefore the quadratic polynomial which fits the given condition is 4x square minus x minus 4. Okay, so now let us move to number 2. So here we have given sum of its zeros is √2 and product of its zeros is 1/3. Okay, so here first we let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. Then alpha plus beta, this is equal to √2, and you can write √2 as 3 times √2 divided by 3, and this is equal to minus b upon a. Okay, and the product of its zeros, that is alpha times beta, this is equal to 1/3 and this is equal to c upon a. Okay, and now if we let a is equal to 3, then b is equal to minus 3 times √2 and c is equal to 1. So therefore the quadratic polynomial is 3x square minus 3 times √2x plus 1. Okay, so now move to 3 numbers. So in 3 numbers we have given sum of its zeros 0 and product of its zeros is √5. Okay, so here we first let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. Okay, so alpha plus beta, this is equal to 0, and you can write 0 as 0 upon 1 and this is equal to minus b upon a. Okay, and the product of its zeros, that is alpha times beta, this is equal to square root of 5. Okay, and this is equal to √5/1, that is equal to c upon a. So if a is 1, then b is 0 and c is √5. So therefore the quadratic polynomial is x square plus √5. Okay, now move to question number 4. So in question number 4 we have given sum of its zeros is 1 and product of its zeros is also 1. Okay, so here we first let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. Okay, so now the sum of its zeros, that is alpha plus beta, this is equal to 1, and you can write this is equal to 1/1 and this is equal to minus b upon a. Okay, and product of its zeros, that is alpha times beta, this is equal to 1. Okay, and this is equal to 1/1 and this is equal to c upon a. Okay, so now if a is equal to 1, then b is equal to -1 and c is equal to 1. Okay, so therefore the quadratic polynomial is x square minus x plus 1. Okay, so now move to question number 5. So in fifth we have given sum of its zeros is -1/4 and product of its zeros is 1/4. Okay, so here we let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. Okay, so now alpha plus beta, this is equal to minus 1 by 4, and the product of its zeros alpha times beta, this is equal to 1 by 4. So this is equal to minus b upon a, and this is equal to c upon a. Okay, so if a is equal to 4, then b is equal to 1 and c is equal to 1. Okay, so therefore the quadratic polynomial is 4x squared plus x plus 1. Okay, so this is the required quadratic polynomial. So these are all about this lecture. So here we will stop this lecture. Okay, so thank you very much to all of you.